Here's the first side of your revision card on this sine rule on non-right angled triangles. So first of all, we're going to find out how to calculate lengths on this non-right angled triangle using the sine rule. Secondly, calculating angles over here. And thirdly, how to calculate the area when the triangle looks in a specific kind of way. So this topic is called the sine rule over here, as you've guessed it, with the area as well. We're going to hit week 15 over here in your revision planner. And this is a grade 7 topic normally found on calculator. Okay, it could hit grade 8 definitely as well, mixed with cosine. We leave a space here for your favorite questions during this video, and hopefully at the end of this video we'll be able to create steps 1, 2 and 3 for you to create your let's do it questions. Let's turn over to our toolkit, please. So on side 2 of your revision card, let's write 3 clear sections A, B and C, in which we're going to create our best important methods for this topic, which you won't forget. These will help you to get through the questions on the sine rule and area. So make sure you have these 3 clear sections, and let's now hit our back to basic questions. Question 1, back to basics. Press pause, write these questions down, parts A and B. Press play when you're ready. So in this topic, we're going to deal with the sine rule, and this is used in particular for non-right angled triangles. So when you see a non-right angled triangle, we can either use the sine rule or the cosine, which we'll do later on. But in this particular case, we're dealing with the sine rule and this area over here. Part A, calculate the unknown length BC, the length, which is this length over here, BC. So first of all, let's pick up 3 particular steps as we normally do for this particular topic. Step 1 is to label your side lengths, and the side lengths will be denoted as such as A, B and C in small letters. So what do we mean by that? Let's say, for example, capital A's denote your angles. The side length opposite that, the length opposite that will be the side length in a small lowercase, i.e. small a over here. So this is capital B with the angle. This will be the side length B. Capital A with the C, small length C. So basically we label A, B and C, and obviously we identify this is the sine rule over here. Now obviously this is the sine rule for this topic, but when you have sine and cosine together, it's a really good way to identify which is which. And there's a really good way of doing this. Let's look at first of all this triangle, and let's look at a full pair, which means that we have an angle and its opposite, a side length fully known. So i.e. we're going to pick the C's over here because both of these are fully known over here. We'll make a little solid bit over here to denote that we know them. So this is called a full pair because we know one full pair over here. At the same time, the question is asking us to find out small a, and we know obviously capital A over here. So we're going to put an arrow over here, and this is going to be a half pair because we know one angle, let's say, but we don't know the other length. So full pair, half pair is pretty a powerful way of understanding how we can identify the sine rule. Okay, one pair fully known, the other one not known. And let's just look at it like this. If I just highlight this, that should make sense from now on. Okay, so step 2 is now to choose what formula to use. Label, identify. Let's do it over here. So step 2, do we want to find the length or do we want to find the angle? So let's choose our formula. Okay, so choose formula we want to use. Now in this case, if it's the length, this is what you have to memorize. This won't be given in the formula sheet. It's A over sine big A equals B over sine big B equals C over sine big C. This is for the length, by the way. Okay, because we find the length over here. Now we've got C and A. We won't be using B in this case. By the way, there's one fraction you'll never be using. So in this case, we'll just cross off B. You don't have to in an exam, but just for here, just to make it easy on the eye, that's better. Once you've got that, you've got chosen your formula. Step 3 is to simply sub in your values. We're going to sub in the values for this. So step 3, let's see what we have over here. Okay, so let's say substitute values. So, do we know what small a is? We don't. Let's write small a. Do we know what big A is? Well, big A is over here. So it's sine 30. Do we know what small c is? Small c is over here. It's 10. Yes, we do. So it's 10. And do we know what big C is? It is an angle sine 100. Now a little shortcut for this is to do this. Now what we do, we have a full pair over here in our fraction. You have to calculate this fully first, okay? So we do 10 divided by sine 100. So if you do 10 divided by sine 100, we're going to get a value of 10.15, okay? So a over sine 30 equals 10.15. Now obviously you would need to write the full number, okay, because obviously this is within this this part of the actual answer, okay? So you write the full answer on your calculator. Now what we do with this is we do this number times sine 30. So if you times this by sine 30, 10.15, as we carry on, times sine 30, we're going to get an answer of this, 5.01. And this is going to be to 3 significant figures. So this is how you do a length scenario over here. Take note of what the steps we did to do this. So part B, let's calculate the unknown angle ABC. So in this case, we're dealing with an angle ABC, this angle over here. So again, this is a non-right angled triangle, we assume, and we're going to be using the 3 steps as above, but a different formula for this for step 2. So step 1 is pretty self-explanatory. We won't do this all again. Let's label small a, small b, and small c. Let's also identify that this is going to be a full pair, half pair. So really quickly, we have the full pair on the A's over here and the half pairs on the B's over here. Step 1 done. Step 2, let's create this correct formula for this. Now, choose our formula. We're going to be doing the flip version of this, and you'll see why in a second. It's basically because we're going to use the same methodology as we did for the length as for the angles over here. The same techniques, so it doesn't confuse you. Okay, so that's step 1 and step 2. Done and done. Step 3 is simply subbing our values. Let's do this over here, in fact. So step 3, we're going to sub. Okay. So let's see what we're going to be using over here. And we're going to be clearly be using these ones over here. The A's and the B's. So we're going to cross out the C's over here, just to make it more apparent of what 2 we're using. We'll cross out the C's. This one goes. Let's just sub in our values in A's and B's respectively. Okay, sine A, where's sine A? Sine A is over here. So sine 60 over a small a, which is 8, equals sine big B, which is x in this case, but sine big B over 4. Right, same thing as before. We have the full pair. Sine 60 over 8. If you do that in the calculator, we're going to get this. We're going to get 0.108, okay, equals sine B over 4. Now, as before, we can cross multiply it, very, very similar. We can say 0.108 times 4 will equal sine B. So, if we go to this stage over here, sine B actually equals 0.43, and it goes on, obviously. Now, obviously, use the full version whenever you are within a question, in the middle of it. Use the full version. Only at the end do we, write it to 1 or 3 significant figures in this case. So now we shift sign this. We do sine minus 1 on 0.43. To find an angle, you always have to shift it. We'll get an answer of 25.7. 25.7 to 3 significant figures. And that's how you would do this question over here. Okay, so look back at this. The 3 steps are very similar for length and angle. The only difference is obviously for angle we flip it, and that's all there is to it. Let's get a toolkit section A out on a revision card of yours. Let's write this formula you've just learned for length of sine rule. So full pair, half pair is the key ingredient over here, in which we identify how to apply the sine rule, and you can see from over here. So press pause, make sure you've got this triangle down, make sure you have your 3 steps on the card, press play when you have got this. This is toolkit B, and this is how to find the angle using the sine rule. So the major difference is step 2 here. You simply flip this formula down. So write this formula and make sure you understand the 3 steps and the example you just did. Question 2, back to basics. Press pause, write this question down, press play when you're ready. So calculate the area of this triangle A, B, and C. So obviously before you are familiar with half base times height as the area of a triangle, this is a second way of using or finding the area of a triangle, should we say. So the first things first is to identify this particular triangle, how it looks like. This triangle has a side length over here, 9.2. Let's call it S. It has an angle, 65, and a side length as well. It looks like this, SAS, with the angle in the middle. When you have a scenario when you have SAS, you can identify it as using the sine rule, and there are 3 simple steps for doing this. The first is always going to be a half, or 0.5. That's your first chunk or your first box. The second bit is to look at either side length, so 9.2 times 4.1 in this case, and that's your second chunk or your second box. The third one is the angle in the middle, so sine 65, and put a third box over here. You simply work this out on the calculator. The answer to the 3 significant figures would be 17.1 centimeters squared. So it's quite easy to do. The trick is just to identify its SAS and then plug in these 3 chunks as you see over here. It doesn't make a difference what is A, B, and C. As long as you see or identify it as SAS, you can apply these 3 chunks. This is the sine formula, so this is section C on your toolkit. And let's get a card and let's write the example we just did. SAS is the key thing over here. Side angle sine is how to identify when and how to use the sine formula. So make sure you understand how to use this like you've just done an example just now. Question 1, call 1. Press pause, write this question down, press play when you have finished. So the diagram shows 2 triangles adjoined to one another. Length AB equals 8 and BC equals 10. Angle ADC over here, this is 66, and DCA, the middle one, DCA 32 is this one over here. Calculate the length of AD. So the length we're finding out of AD, so AD would represent this length over here. So how do we find out this? So first of all, let's see what we know over here. So first of all, let's look at this triangle and let's pick up a key feature. This key feature obviously is a right-angled triangle. Now, right-angled triangles should be synonymous with either trigonometry or Pythagoras' theorem. Now, when you have an angle involved with a right angle, it's trigonometry. When you don't have an angle involved, it's going to be Pythagoras. There's no angle within this triangle. There's no angle here or no angle here apart from the right angle. It's going to be Pythagoras. Really quickly, 8 squared plus 10 squared would give us AC squared. Let's do this over here. So Pythagoras, we'll say 8 squared plus 10 squared would give us AC squared. So 164 would give us AC squared. The square root of 164 would give us AC. Therefore, AC would be 12.81. Okay, in this case, obviously use the full number because this is intermittent within the question over here. This is 12.81 as such. Okay, now we look at this triangle over here, and obviously this is a non-right angled triangle because all 3 don't add up to 180. So it's going to be the sine rule. Well, let's use the sine rule over here. Let's identify your small lengths. So we'd call this one over here small c, small a, and small d, let's say over here. Okay, we're going to do the full pair, half pair. Let's see if this works. So full pair, here's the full pair over here. We have both angle and length known of d, and half pair over here. Don't worry too much about the letters, as long as you've got the full pair, half pair. That's the key objective over here. So step 1, we're done. Okay. Step 2, let's use the correct formula. The correct formula obviously is to use A over sine big A equals B over sine big B over C over sine big C, because we're using length in this case over here. Step 3, let's sub our values in. Let's do this. Let's highlight these. So identify it and label correct formula, sub in our values. This is what we have. So we have basically 12.81, let's say, over sine 66 equals sine, not sine, C should we say. We'll have C in this case because we're finding out the length. So we have C over sine 32. Let's work out this one in one go over here. Do 12.81 divided by sine 66. We should get 14.02 equals C over sine 32. Put a 1 there. Let's cross multiply. Let's do 14.02 times sine 32. So we get an answer. C would equal 7.433 significant figures. So that's very similar, in fact identical to what we did before in terms of using the 3 steps to use sine rule, but all we've done here is apply it within a Pythagoras theorem at the beginning. Question 2, core 2. Press pause, write this question down, find the area of this triangle, press play when you're ready. So the diagram shows triangle AB and C. AC equals 4.3 and CB equals 7.3. Angle ABC is 34 degrees over here. Find or calculate rather the area of this triangle. So the first thing we're going to do when we see this is, you know that basically to use the sine area rule, we have to have a triangle looking in this way over here. Side, angle in the middle has to be known, and a side over here. If you don't have these 3 features in this order, you can't use the sine area rule. Could we use this? No, because we have a side over here, a side and an angle over here. It doesn't look like this, we can't use it. So how could we best use the numbers and data over here in order to find or possibly create a triangle like this? Let's straight away look at this. We have a full pair and we have a half pair over here. We have 2 clear signs that we could use. Another idea called the sine rule. Not the sine area, but the sine rule, okay? So a full pair and a half pair. So let's see what we can do with this. So we're going to first of all write this down. So sine 34 over 4.3 equals sine A. This is the angle we want to find out, by the way. Angle X over 7.3. Let's divide this full fraction, the full fraction pair together. We're going to get 0.13 equals sine A over 7.3. Put a 1 there, we'll cross multiply. So therefore, sine A, if we do 0.13 times 7.3, we're going to get an answer of 0.949. We'll simply shift sign this answer. So in fact, we'll do it like this. So A will equal sine minus 1, 0.949. And we will get an answer of 71.6 degrees. So that is basically this over here. This is 71.6 degrees. Now we have 2 angles in this triangle. We have this one and this one. All 3 add up to 180 obviously. So let's add these 2 together and let's take it away from 180. So if we do this, if we do 71.6 plus 34, which is going to be 105.6, and 180 take away 105.6, we're going to get an answer of 74.4. So 74.4 is this angle over here. This is going to be 74.4. So therefore, we could say with certainty that we have SAS. We have a side, angle, side. We have a side over here. We have an angle over here. And we have a side over here. Just like this. Side, angle, side. We can chunk this up into 3 steps. And we go ahead with this. We can say we have half times 4.3 times 7.3. And then the whole thing, the third chunk, times sine 74.4. If we do this on the calculator, we're going to get an answer of, let's work this out. So sine 74.4, we're going to get an answer of 15.1 centimeters squared. So that would be your answer of how you would do this. Look back at this and see how we've created an SAS scenario to fit the purpose of creating, or working out rather, the sine area formula. Question 3 challenge. Press pause, write this question down of this footpath, find the perimeter and press play when you're ready. Footpath comprises of both an arc WXY, so WXY is this path over here. There we go. And also it comprises of a partial triangle WZY. So it's this line segment WZ plus another line segment YZ. So it's 3 different parts to this footpath. The arc WXY, a line segment WZ plus another line segment YZ. The arc is 9.6 kilometers. So this whole curve, this part of the sector, the arc is 9.6 kilometers and forms part of a sector radius 5 kilometers. WOZ is a triangle. We can see it over here, obviously, center 0, and angle WOWZ is 41 degrees. calculate the perimeter of the footpath. So basically we're going to add up three things together. The footpath comprises of three different parts. So first of all, it's the arc of WX, Y. Secondly, it's the line segment over here, WZ. And thirdly, it's this line over here, YZ. Alright, so these are the three parts we need to outline individually and figure out. Now we know this one already. The arc of WXY is already 9.6 kilometers, so that's pretty good if given us this. But we don't know this one, we don't know this one over here. So these two are the ones we need to find out. So let's try to figure out what we have and work backwards from this. We have 9.6, which is the length of this arc over here, WXY. And let's try to figure out backwards what information we can get from that, okay? So to have figured out 9.6, we would have had to have done backwards x over 360 times pi d. Pi d is simply going to be 10 pi over here, and that would equal 9.6 kilometers, so 9.6 in this way. Imaginary 1 under every number. When you multiply two fractions, top times top and bottom times bottom, we can represent this as 10 pi x over 360 equals 9.6. Again, we can cross multiply over here, and we can say basically that 10 pi x would simply equal 3, 4, 5, 6. If we divide this now, x would be 3, 4, 5, 6 over 10 pi in brackets, and if we do that, we get an answer of 110 degrees. So this would be 110 degrees over here as such. So WZ, what can we work out? Well, first of all, before we do anything, let's try to work out this angle over here. We know all three angles add up to 180. 110 plus 41 is 151. 180 take away 151 is 29 degrees. Now, WZ, let's have a look at this. We can clearly use a full pair, half pair over here. We have a full pair of these two over here, 5 and 29, and a half pair over here. So WZ, let's do this. So we can say basically that 5 over sine 29 equals, let's say, x, which is WZ in this case, over sine 110. Let's work out a full fraction for this. So 5 divided by sine 29 simply just gives us 10.31. And this is WZ over sine 110. Let's put a 1 over there. We multiply 10.31 times sine 110. And we get an answer of 9.69. Okay, 3 sig figs. That basically is this length over here, WZ, 9.69. Let's just highlight all of these, by the way, so you understand where we're coming from. So this is 9.69. We're finding out WZ. We find out obviously 110 over here. Okay, we've got 9.6 already as well. Let's do the final version over here. We want to find out now YZ. So YZ, let's maybe do it over here. So YZ is our final part. Now to find out YZ, common sense tells us let's find out OZ first and take away OY from that. OY is going to be 5 kilometers. That's the radius. So Y to Z, let's do this over here. And again, we can figure out a full pair, half pair scenario with this. So we have 5 over sine 29 equals, let's say, it's a 5 and this one. And we have 41 and we have this one over here, OZ. So we can say OZ over sine 41. We know that this divided by this from the previous example was 10.31 equals OZ over sine 41. Put a 1 over here. So we can now do a bit of cross multiplication and we can say that 10.31 times sine 41 will equal OZ. So OZ will equal 6.77 kilometers if you do the maths behind that. And that will be your answer for YZ. Sorry, not OZ. This will be OZ over here. And to find out YZ, obviously, we take away 5 from this. So, yeah, so take away 5 from that because OZ, take away OY would give us YZ, if that makes sense. YZ will be, take away 5, we're going to get an answer of 6.77, take away 5, 1.77 kilometers. So let's add all these three things together now, okay? We've got different numbers here to represent everything. That should be the main one, sorry, 1.77, not the 6.77. let's add up all of them together. So we've got 9.66 plus, let's do it over here in fact, 9.6 plus 9.69 plus 1.77. If we do that, we're going to get a final answer of 21.1 kilometers. So that would be the final answer of the footpath for all three parts of this. So again, look through this question and make sure you understand how we did this. So now this brings us to the end of our chapter over here. So your revision card should look something like this. Let's go through each one of these key objectives. So you should know what formula to use for calculating lengths, and even know the formula for this. A, small a over sine big A equals B over sine big B equals C over sine big C. Also, you should know how to calculate angles using the sine rule. You just flip the one above, so it's sine big A over A equals sine big B over B equals sine big C equals C. Okay, that's section B on our toolkit. And thirdly, you should know how to calculate the area of any triangle. This has to specifically look like SAS for you to do so. So these are the three things you've understood, and let's go through these steps as well. You should learn how to label and identify the sine rule at the beginning using a full pair over here and a half pair. Any triangle would have this. Step 2, you choose a formula being your length or your angle over here, which you already know from sections A and B. And thirdly, we substitute our given values to find out the value of what we want to find out, the length or the angle. So make sure you have this card filled in, obviously with your example. Let's turn over to consolidate our main toolkits before we start these questions. So this is our final toolkit before we do our Let's Do It questions. And make sure you've got this down on your cards. These are your 3 different tips and tricks. So how to find the length using the sine rule, how to find the angle, and lastly, how to use the sine area formula for SAS. Full pair, half pair is the key ingredient of how to identify the sine rule on Maths Memory on this video so far. So press pause and let's do the questions based on this information. Question 1, let's do it. Press pause, write this question down, and press play when you're ready. Question 2, let's do it. Press pause, write this question down on the area of this triangle and find the angle ABC. Press play when you're ready. Congrats, you've now finished the sine rule and should now be in a much better position to understand, identify sine based triangles. So look back on the questions, look back and go over where you've made mistakes, where you've went well, look back at your cards, and obviously go to your revision planner right now and rate yourself on your feel good factor. Hopefully you're hitting that flow factor right now, and you want to do really well in this. So pause this, give yourself a pat on the back, and well done.